quadratic formula. As you saw with the quadratic formula, it was two fractions, negative b over 2a, plus or minus the square root of b squared minus 4ac all over 2a. Now that expression inside of the square root symbol, the b squared minus 4ac, that is known as our discriminant. The discriminant is going to become a value that's going to determine how many solutions there are and what types of numbers they're going to be. Now, they're mostly two, but sometimes you can have just one answer. All right. So we're going to create a table for the discriminant to tell us exactly what our values are going to give us in terms of how many answers and what types of numbers they are. All right, so if your discriminant, b squared minus 4ac, is less than 0, which means it's negative, that means you have a negative inside your square root. You're going to have two imaginary solutions. So if there's a negative inside of the square root symbol, that's the discriminant value is negative. You have two imaginary solutions. If my b squared minus 4ac is equal to 0, then there will be one rational solution. So what happens is if that square root becomes 0 on the inside, and we take the square root of 0, which means 0 is in the numerator, and we're dividing it by 2 times some value other than a 0, so we'll call it 0 over 2. That whole fraction becomes a 0, and we're adding and subtracting a 0. So technically, your one single answer is the negative b over 2a. And since negative b over 2a is a fraction, that makes it a rational solution. So what we're left with is now if b squared minus 4ac is greater than 0, which means it's going to be positive. Well, this will fall into two categories. Will my b squared minus 4ac be a perfect square? This is my case 1. And how do I determine if my b squared minus 4ac value is a perfect square? Because sometimes they're going to be 3 digits long, 4 digit long. You just go grab your calculator, take the square root of that value, and if you get an integer back, no decimals attached, it's a perfect square. So if it's going to be a perfect square, then there will be two rational solutions, which means, again, on that second fraction of your quadratic formula, the square root symbol completely simplified away. It is no longer part of the numerator, and so therefore we're going to add and subtract a rational fraction to our existing rational fraction. Case 2 is, okay, what if b squared minus 4ac is positive, but it's not a perfect square? This is when you take the square root of the value and you get a decimal. Okay, then there will be two irrational solutions. So you have 4 possibilities that are going to occur. And we'll take a look at an example of all 4 so you can be aware of. Now, when we take the test, you have to calculate out this value. Have it on your test. Just don't go to your calculator and find the number. You have to write this out. So here are some examples. The directions will say, for each equation, determine how many solutions and what type of numbers exist. This might be a drop-down window, and it gives you all 4 possibilities. It could be a text box that wants you to type in how many solutions are, and then a drop-down window of what type of numbers that you have. So pay close attention to the directions for the homework. So here you want to take your b squared minus 4ac. You want to identify the a value. Ax squared plus bx plus c. A is going to be 9, b is going to be a negative 12, and c is going to be a positive 4. Now, when you crunch this out, remember negative 12 is going to go in for b, and you have to use parentheses. All right? Now, I know if I type in negative 12 and you square it, that will come up to be a negative 144 if you don't include the parentheses. You have to show me the substitution. Negative 12 in parentheses being squared minus 4 times the a, which is 9 in parentheses, times the c, which is 4. You need to write this down. But when we type this in the calculator, we know that, oh, anytime you square a number, it's always going to be positive. So instead of typing in left parentheses a negative, 1, 2, parentheses, how about we just type in 12 squared? Save yourself 3 button pushings. So 12 squared minus 4 times 9 times 4. This is a 0. So you need to say, okay, this equals 0. Tell me what the value is. And based on that value, you have one rational solution. My next example, we have x squared plus 5x plus 8. So again, identify your a here. There's no number in front of the x squared, so a is a 1, b is a 5, c is 8. Then show the substitution. Okay, 5 squared minus 4 times 1 times 8. There's the substitution you want to write down. Go to your calculator, crunch the numbers. We get negative 7. Put down equals negative 7. Write that down. And based on that solution, being negative, I have two imaginary solutions. Both answers are going to have the I in the answer. Next, we have 2x squared plus 7x minus 3 is equal to 0. Identify a as 2, b is 7, c is negative 3. Show the substitution. 7 squared minus 4 times 2 times negative 3. Go to the calculator, we'll crunch that out. We get a positive 73. All right, 73 is not a perfect square, so you're going to have two irrational solutions. That means you're going to be left with a plus or minus a radical in the numerator. Next example, we have 6x squared, so a is 6 plus 13x, b is 13, and c is the positive 6 at the end. Show the substitution. 13 squared minus 4 times a, which is 6, times the c, which is 6. Go to the calculator, we type that in, put down equals 25, and based on that value, 25 is a perfect square number. You have two rational solutions. So here there'll be no square root left over in the numerator of the second fraction. It'll become just 5 over something. And then you can have two rational solutions because there'll be no square root in the answer. Another thing we want to discuss in 11.3 is writing quadratic equations given the solutions. Now, a lot of authors do this completely wrong. So I'm going to show you one technique that works all the time. And it's basically going to depend on what type of numbers you're given. So if we go back and we talk about rational, imaginary, irrational, rational. Rational solutions are answers that can be written as a fraction with no square roots and no i's. So this is 3 over 1, negative 7 over 1, 2 over 1, negative 4 thirds, 2 over 1, 0 over 1, negative 1. These are all rational solutions. And these are the answers that we acquired when we solve by factoring. So what we're going to do is we're going to work that backwards. So here we're going to take x equals 3 comma negative 7. We're going to set each number equal to an x. And then we're going to take each one of these equations and set them equal to 0 to turn them back into binomials. So we'll subtract over the 3, add over the 7. So now I have the binomial x minus 3 equals 0, x plus 7 equals 0. You probably remember that when we're solving by factoring. Then we're going to take those two parentheses, bring them together, and FOIL it out. X times x is x squared, x times 7 is 7x. minus 3 times x minus 3x minus 3 times 7 is minus 21. Combine your two middle terms. 7x minus 3x is a positive 4x. This is the quadratic equation that you are looking for. Okay? Next, x equals 2 comma negative 4/3. All right, set each one equal to x. Now we're going to set these equal to 0, but remember when we had a fractional answer, the last thing we did was divide the 3 from the x over to the negative 4. So we're going to multiply that 3 back over first. So there's no fractions. Now set them equal to 0. So subtract over the 2, add over the 4. Grab those two binomials, x minus 2 and 3x plus 4. Put them in parentheses. We'll FOIL this out. 3x squared plus 4x minus 6x minus 8. Combine those two middle terms. 4x minus 6x is equal to negative 2x. So there is my quadratic equation. Now, we can actually work with 3 factors here, but it'd be really nice if they always give us a 0, because this is already done for us. X equals 2 and x equals negative 1, we're going to have to subtract over the 2 and add over the 1. So this x equals 0, this was probably a GCF factor here that we factored out of all 3 terms first and then factored the trinomial. So don't multiply this GCF first. Save it for last. So go ahead and FOIL these two binomials first, and then we'll distribute it at the end. So x squared times x squared is, x times x is x squared. X times 1, there's my 1x. Negative 2 times x minus 2x. Negative 2 times 1 is my minus 2. Combine like terms in the middle, get a negative or minus 1x. Now distribute your x to all 3 terms. X cubed minus 1x squared minus 2x equals 0 is our answer. All right, again, rational values. Now we're going to look at irrational and imaginary. These you cannot do by this technique of doing your factoring backwards. You've never factored anything and got square roots in your answers or imaginary numbers in your answer. But what you have done is complete the square and got these answers. So we're going to complete the square backwards. So instead of writing these as 2 separate x equals, we're going to write it as 1 plus or minus. Now, the goal here is to get rid of the square root symbol. So in order to get rid of the square root symbol, since this plus or minus 5 square root of 3, it's its own term right here, you're going to square both sides. Well, x being squared will be x squared. Positive or negative being squared will automatically be a plus or a positive. 5 squared will be 25. And the square root of 3 being squared will be just a 3. So 25 times 3 is 75. Now set it equal to 0. We just subtract over the 75. And there's my quadratic equation. What authors are going to ask you to do, which I think is absolutely crazy, is that they want you, and I'm going to do both of them here so you can see them done. These two right here. They're going to ask you to do the following. Oh, well, think of this as x equals 5 square root of 3. X equals negative 5 square root of 3. Write them as binomials equal to 0. Come on, pen. And then they want you to FOIL this out. I say no, because multiplying with these radicals get ugly. Now, if we take a quick look at this one, look at the pain this would be. This would be x, add over the 2, subtract over the square root of 5. Then it would be x, add over the 2, add over the square root of 5. Now, I don't know about you, but these are no longer binomials. Those are two trinomials that you would have to multiply together. That could take some time. Now, they might say, oh, well, look what you got here. Those two terms are the same. You have a conjugate pair, and you could write this out as x plus 2 squared minus the square root of 5 squared equals 0. And then you still got to FOIL this. You still got to square the second part. And I'm not a fan of doing this. What I am a fan of doing is working with what gave me those answers. So, let's do this one up here. 2i minus 2i. And don't be surprised if they just give you one of these. Sometimes they'll say x equals 2i. Then you automatically have to have a negative 2i. It's automatic. But again, if we set it as a plus or minus, we square both sides. Positive and negative becomes a positive when you square it. 2 squared is 4. I squared is I squared. But we know that I squared is also equal to a negative 1, which now makes us x squared equals negative 4. Add the 4 over, and x squared plus 4 equals 0. And there is my quadratic equation. This doesn't factor to two rational solutions, but it does factor to these two imaginary numbers. Now, over here, again, think about all the foiling I just described. We write it as negative 2 plus or minus the square root of 5. That's just the way we saw our answer when we completed the square. The last thing we did in complete the square is we subtracted over the 2 in front of the plus or minus. Okay, add it back over. Get this square root by itself. Once it's by itself, square both sides. Here comes the x plus 2 squared. That's going to be x squared plus 2x plus 2x plus 4. Or remember the smile technique, x times 2 is 2x, double it to a 4x. And the square root of 5 being squared is 5. Subtract the 5 over to the 4 makes it a minus 1. There's my quadratic equation. And this works for the imaginary numbers as well, because I is technically the square root of a negative 1. So we'll write this as x equals 4 plus or minus the 3i. That's just the way we saw it when we did completing the square. Subtract the 4 back over. You want to isolate the radical. That's the I. Square both sides. All right, x squared minus 4x, double it to minus 8x. And then negative 4 times negative 4 is plus 16. Combine these together to get your minus 8x. 3 squared is 9. I squared is I squared. Remember, the plus or minus disappears because it becomes positive. I squared is a negative, so 9 times negative 1 is negative 9. Add the 9 to the 16, we get x squared minus 8x plus 25 equal to 0. All right, 11.4, word problems. Now, these word problems are going to make quadratic equations. So the first ones we're going to look at are distance formulas. Not the distance formula between 2 points, but distance equals rate times time. Fiona rode her motorcycle 300 miles at a certain average speed, which is also known as rate. Had she traveled 10 miles per hour faster, the trip would have taken 1 hour less. What was Fiona's average speed? So what we need is a table. 2 rows, 3 columns. Distance equals rate, or your speed, times the time. And now, when they talk about miles per hour, they got to make sure that they give you your time in hours. If they give you time in minutes, you got to convert it into an hour. They like to be sneaky with 15 minutes, 30 minutes, 45 minutes. You have to change that into a fourth of an hour, a half hour, 3/4 of an hour, things of that nature. Okay, so we had an original trip and the what if trip. In both cases, we traveled 300 miles. In the original trip, we went R miles per hour. In the what if trip, if we went 10 miles per hour faster, okay, that'll be R plus 10. And your time, well, we'll just call T for time in the original trip. Then 1 hour less in the what if trip will be T minus 1. So this first equation is 300 equals R times T. This one is 300 equals these two binomials. Now, the problem that I have right now is that I have two equations with two variables. They want me to solve for Fiona's average speed. That's R. So I need an equation with just R in it. Okay, so what that means is I got to take a look at one of these two equations, the first or the second. Which one would be the easiest one to solve for T? You're right, the first one. If we take this first equation and we divide the R over to the 300, so T is equal to 300 over R, and take this fraction and substitute it into that T right there, that would give me this new equation. And now notice there's only one variable in the equation. There's R in the R plus 10 and 300 over R minus 1 in the second binomial. So to solve this, we have to FOIL it out. So R times 300 over R, that will cancel the R's to give you 300. R times minus 1 gives me minus R. 10 times 300 over R is 3,000 over R. 10 times minus 1, minus 10. All this equal to the same, wait a minute, these two 300s here are exactly the same. So if I subtract 300 from both sides, that cancels it out and makes it 0 equals negative R plus 300R minus 10. Now, to solve this is we have to get rid of the R in the denominator. And so that means I got to multiply both sides of the equation by R. Well, if I do that, this will become a negative R squared. And I prefer to have my variable squared be positive. So I'm going to opt to multiply all my terms by a negative R. Well, 0 times negative R is 0. This becomes R squared. R in the bottom, R being multiplied will cancel, which makes my 3,000 a minus 3,000. Minus 10 times minus R makes that a plus 10R. Okay, so here's my quadratic equation. I just need to put it in descending order. So I put my plus 10R in the middle, and now I'm going to factor this. Now, we talked about this once before. Remember numbers that end in zeros and add up to be a 0 or subtract to be 0? My numbers must probably end in 0. So you take away those two zeros, take away this 1 0. What two numbers multiply to be 30 and subtract to be 1? 6 and 5. Add the zeros to them. Okay, 60 times 50 is 3,000, and 60 minus 50 is 10. As long as we make the 60 the plus, the 50 the minus, we solve for this. R equals negative 60 and wait a minute. Can't have a negative, right? So we'll have to throw that one out. R is equal to 50 in my original problem. So Fiona went 50 miles per hour. Now, if you want to check to make sure that all this works out, we plug this in. 50 for the R, 50 plus 10 would be 60. So if 300 divided by 50, that's a 6 for T. 6 minus 1 is 5, and 5 times 60 is 300. It makes both of them true. Our next word problem. Here we have, during the first part of a trip, Tara's Honda traveled 120 miles at a certain speed. Tara then drove another 100 miles at a speed that was 10 miles per hour slower. If the total time of Tara's trip was 4 hours, what was her speed during the second part of the trip? Okay, 2 rows, 3 columns. First row, that's going to be the first part of the trip. Which said she went 120 miles at a certain speed. Call it R because I don't know what it is. And let's see. They didn't tell me anything about the time. Okay. Then she went 100 miles on the second part of the trip, which was 10 miles per hour slower. So this is R minus 10. All they told me was the total time was 4 hours. So what I'm going to do is I'm going to call the first part time T sub 1. The second time will be T sub 2. And these two have to add up to be 4. Now this is where I'm going to create my equation from. So I have to take this first equation, 120 equals R times T sub 1, solve it for T sub 1, divide over the R, just like I did a lot in the first problem. Then take this T sub 1, 120 over R, substitute it in right there. And do the same thing with this equation. 100 equals R minus 10, in parentheses T sub 2. Do not distribute the T sub 2. Just divide over the R minus 10. Take this fraction, substitute it down here, and set it equal to 4. Now, since we're trying to find what is the speed of each part of the trip, that's the R's, I now have an equation with R in it. So since this R minus 10 technically is in parentheses, to get rid of these two denominators, I must multiply all the terms by the common denominator, or least common denominator, R and R minus 10. So we will take both denominators and we're going to multiply it to every single term. Now, I wrote this out so you can see what happens. And then soon you won't write it out because you know we're doing this because we want this to happen. The R canceled. The R minus 10 canceled. So in the future, we see what's going to cancel, then don't write it down just to cross it off. So we have 120 times R minus 10 plus 100 times R equals 4R times R minus 10. Now, I noticed that here's 120, here's 100, and here's 4. All these coefficients are divisible by 4. So if you want to right now, instead of working with huge big numbers, you can work with small numbers. Let's divide 4 from every term. And that makes things smaller. 30 times R minus 10, 100 divided by 4 is 25R, and now we just have to distribute the R instead of 4R. So distribute the 30, 30R minus 300 plus 25R, R squared minus 10R. Here your R squared is positive, so let's combine our like terms. 30R plus 25R is 55R, and now we're going to move these two terms over to the right side because we want to keep R squared positive. So negative 10 minus 55 will be a negative 65R. Add over the 300. So we're looking for what two numbers multiply to be 300 and add up to be 65. Okay, hint, 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 since it ends in zeros, one number ends in 0, one has to be a 5, so the only thing I can think of is 60 and 5. So R minus 60, R minus 5. So R is equal to 60 and R is, wait a minute, how can we have two rates? Wait a minute, well, wait a minute, look what happens, look what happens. Look at this R equals 5. Is it possible to go a rate of 5 miles per hour and then the second part of the trip subtract 10? That would mean she's going minus 5 miles per hour. You can't have a negative rate. So we're going to throw that one out and say, okay, first part of the trip, she went 60 miles per hour. And then the second part of the trip, she went 60 minus 10, 50 miles per hour. And there's my two answers. All right, the Hudson River flows at a rate of 3 miles per hour. A patrol boat traveling at a constant speed travels 60 miles upriver and returns in a total time of 9 hours. What is the speed of the boat in still water? So we're trying to find rate. Okay, 2 rows, 3 columns. Distance equals rate times time. Our boat is traveling upriver, and then it's coming back downriver. And so 60 is the distance when it goes upriver. Now its speed is R, but we have the river, its current is going to adjust our speed. So when I go upriver, I have to fight the current. So that's going to take that 3 miles per hour and subtract it from my boat speed, which means I can't have a boat speed of 3 or less because then I can't make it upriver. The time, I don't know. So coming back downriver, same distance, 60, but now the current is going to help push my boat, R plus 30. I'm actually coming back faster than when I came up. Now, which tells me that these two times can't be the same. If it took me a slower rate to go 60 miles, then my time has to be bigger here than when my rate was faster. Now my time will be less. So these two times aren't the same. So just like I did earlier with t sub 1, t sub 2, add it to be 9, call it t sub up and t sub down. There's my equation, but we have to get rid of these t's. So first row, 60 equals r minus 3 times t sub up, divide over the r minus 3, substitute it down here for that t sub up, plus. Do the same thing with this line. 60 equals r plus 3 times t sub down, divide over the r plus 3, 60 over r plus 3, plug it in for t sub down. There's my equation with only r's in it, so now I can solve for the rate. So these two denominators are different. It's r plus 3, r minus 3, which happens to be a conjugate pair. I can see that it's going to cancel. So again, I think about if I multiply these two to this, the r minus 3 cancels, leaving me 60 times r plus 3. If I take these two binomials and multiply it to the 60, I see the r plus 3 is canceling, so plus 60 times r minus 3 equals 9. And again, this is a conjugate pair, which gives you r squared minus 9. Again, I want to make numbers smaller. I notice that 9, 60, and 60 are all divisible by 3, so I'm going to make numbers smaller. Again, this is optional. You don't have to do it. It gives me 20 times r plus 3 plus 20 times r minus 3 equals 3 times r squared minus 9. Now, we set this equal to 0, but we have to distribute. 20 times r plus 3, 20 times r minus 3 is going to give me 20r plus 60, 20r minus 60. Those two are going to cancel. Bonus time, get rid of them. 3 times r squared minus 27. Let's add the 20r's together, get 40r. My r squared is positive on the right. Subtract over the 40r. And now we'll try to, wait a minute. Ooh. Let's see, it's either 3 times 27. That's going to subtract. I'm going to have 24 or 9 and 9. Nope, this does not factor. So we're going to have to use the quadratic formula. So r equals negative b. So negative 40. That's why this is a positive 40. Over 2 times a, 3. Negative 40 squared. Remember we say we'll just put in 40 squared because that's always positive. Minus 4 times a is 3 times negative 27. Again, notice that this reduces. 2 goes into 40 20 times. So that means that once my calculator gives me this value of 1,924, I'll be able to simplify that. However, we probably don't need a simplified radical answer. So we're probably going to find decimal answers. So we'll just go to the calculator. 20 divided by 3 plus the square root of 1,924 in parentheses divided by 6, 13.9777, which is approximately 14 miles per hour. If I put in the minus sign, I get a negative rate, which we'd have to throw that out. And they'll probably say round to the nearest whole number. And so there's my answer. All right, 2 pipes are filling a pool together. They can fill the pool in 3 hours. Pipe A can fill the pool in 8 hours less than pipe B, working alone. How long does each pipe take when working alone. Okay, this was that work principle formula we talked about, T over A plus T over B. All right, little a will be pipe A, pipe B will be little b. All right, so let's see. It said pipe A can fill the pool in 8 hours less than B. So we don't know anything about B. Keep B the same. A becomes B minus 8. T is the total time, which is 3, so we put those in the numerator. So here we have, just like the previous problem, we have to multiply these two denominators together, b times b minus 8, multiply it to, so I can see when I multiply this to here, b minus 8 cancels out, b is going to be multiplied to my 3. Here the b cancels out, b minus 8 times my 3, and 1 times b minus 8. 3b, 3 times b, 3 times minus 8 is minus 24. B times b, b squared, b times minus 8, minus 8b. Combine this together to get 6b minus 24. Here's my b squared, it's positive, so let's subtract over the 6b, add over the 24. B squared minus 14b plus 24. What two numbers multiply to be 24 and add up to be 14? How about 12 and 2? So b minus 12, b minus 2. So b is equal to 12 and b is equal to 2, but again, 2 cannot work because 2 is less than 3. So if pipe B can fill that pool in 2 hours, then there's no way they would have been 3 hours working together. So that's unreasonable. So pipe A is going to be 12, that B, minus 8, which is going to be 4 hours. So pipe B was 12, pipe A was 4 hours. Using the formula 4.9 t squared plus v sub 0 t equals s. A ball is thrown downward with a velocity of 30 meters per second from a 100-meter tall building. How long does it take to hit the ground? V sub 0 is the initial velocity and s is the height. So 4.9 t squared plus 30, that's going to be my velocity. And my height is 100. Subtract over the 100, keep your 4.9 t squared positive. Definitely a quadratic formula here. We'll substitute in our numbers, negative 30 for the b. 4.9 times 2 is 9.8. Then we'll do the b squared, so we're going to go 30 squared minus 4 times 4.9 times negative 100. My calculator, I just crunched that right away, 53.4789. Let's go to 3 decimal places. And then negative 30 over 9.8 minus, that will give us a negative answer. So let's just add them together. Negative 30 divided by 9.8 plus, and what I did is I took this answer, stored it for x, over 9.8, so the first one's 2.395, can't have a negative time, so time is approximately 2.4. Again, we'll round it to wherever the direction tells us to round. All right, a equals 2 pi r squared plus 2 pi r h, solve for r. All right, this we're going to turn into a quadratic equation, set it equal to 0, so we're going to subtract over the a. The reason it's quadratic is because you have an r squared and an r to the first. And I'm going to use the quadratic formula. So I subtracted over the a, here it is. So a is 2 pi, b is 2 pi h, and c is the negative a. R squared, there's a, here's r, so 2 pi h is the b. We're going to substitute it into the formula. Yeesh. Negative 2 pi h over 4 pi. Okay, we can simplify this. 1 over 2, pi's cancel, so a negative h over 2, plus or minus. Now we're going to focus on this. Now remember, because this reduced, I'm going to be able to simplify this. this becomes 2 squared, which is 4, pi squared h squared, minus, let's see, minus a negative, that's going to be a positive 8a pi h. Now the only thing I see common between these two is a 4 as a GCF. Factor that out. There's my parentheses. Now yes, there's a pi symbol here. But if I did factor this out as 4 pi, I would not be able to take the square root of just pi to the first power. So the square root of 4 is 2. Put that up here. 2 goes into 4, cancels out. There's my answer. Now if they want this as one fraction, then we don't want to cancel the pi's. We put that negative h pi all over 2 pi. Sometimes you're going to want just one answer.